Let's take a look at the standard form of a quadratic function, or we call it the vertex form. The quadratic function f of x equals a times x minus h squared plus k, where a is not 0, is in standard, or what we call vertex form. The graph of f is a parabola whose axis is a vertical line, x equals h, and whose vertex is a point, hk. When a is greater than 0, the parabola opens up, and when a is less than 0, the parabola opens down. To graph a parabola, it is helpful to begin by writing the quadratic function in vertex form using the process of completing the square. So example 2, using vertex form to graph a parabola. I know your textbook refers to it as standard form, but I think we're used to hearing this as vertex form. So we're going to sketch the graph of f of x equals 2x squared plus 8x plus 7. Then we have to identify the vertex and the axis of the parabola, or the axis of symmetry. So this is how we're going to complete the square. We'll rewrite the problem. F of x equals 2x squared plus 8x plus 7. So first, we're going to take the first two terms. We're going to factor out a 2, just a 2. And then now we have x squared plus 4x. And we're going to add some value, and then plus 7 at the end. And then we're going to subtract that value, but we have to subtract it times the 2 since we pulled it out. Okay, so if we add it on this side here, we have to subtract it in order to balance it out. And that has to work because this is multiplied by 2, right? So that has to be the same thing on this side. So we have x squared plus 4x to complete the square. We know the process is 4 divided by 2, and then we square it, so that answer is positive 4. So this becomes 2 times x plus 2 squared plus 7 minus 8, or 2 times x plus 2 squared minus 1. So now this is in our vertex form. So now we can quickly identify a vertex, which is -2, -1. So we graph that, -2, -1. We know, first of all, the y-intercept is at 7. Then we can use our pattern of 1, 3, 5, but remember we need to multiply 2 to it in order to get the pattern. So it's going to be 2, 6, and 10. So at -2, -1, we go right 1 up 2, right 1 up 6. And notice that is at our y-intercept of 7. So here is our graph. It's a little wavy. And then we know that our axis is here, which is at the x value of the vertex, and that is -2. So why don't you try this example here. Sketch the graph of 3x squared minus 6x plus 4. Identify the vertex and the axis of the parabola. Please use the completing the square method to get some practice on that. Try this out. This is what you would have gotten. Okay, you just factor out the 3 out, and then you added a 1, and then subtracted the 3 times 1. And when you finally finish, your function would look like this, with the vertex at 1, 1, and the axis at x equals 1. Don't forget the vertical stretch by 3, and you could always double check because you know the y-intercept is 4, so you should have hit 4 at that point. Example 3, finding the vertex and x-intercepts of a parabola. So we're going to sketch the graph of f of x equals -x squared plus 6x minus 8. Then we're going to identify the vertex and the x-intercepts. So we're going to, again, complete the square for this one. So we'll factor to negative. So it's x squared minus 6x plus blank, and then minus 8, and then minus a -1 times whatever I add. So this is going to be -6 divided by 2 squared, which is going to be 9. So this becomes -x minus 3 squared minus 8 plus 9. So this will be -x minus 3 squared plus 1. So we know our vertex is at 3, 1. Then in order to find the x-intercepts, I know we could graph. The other way we could do it is algebraically. So we can go ahead and factor. And so I'm going to factor x squared minus 6x plus 8. I'm going to just factor out the negative. And so when we factor, we know this is x minus 4, x minus 2. So our x-intercepts are at 4 and 2. And so we write that, if we're writing intercepts, write it in ordered pair. So 4, 0, 2, 0. So it's our x-intercepts. So the vertex is at 3, 1, right 3, up 1. We know that it's opening down. So left 1, down 1, left 1, down 3, right 1, down 3. And here is the graph. We know our axis is at x equals 3. And so we are done with this one. So go ahead and try the next example. Sketch the graph of x squared minus 4x plus 3. Identify the vertex, the axis of the parabola, as well as the x-intercepts. So if you tried it out using the completing the square method, you would have gotten this function. The vertex is at 2, negative 1. Our axis is at x equals 2. If you factored it out, you would have found the x-intercepts to be 1, 0, and 3, 0. And so here is the graph. I hope this helps, and thanks for watching.